We know y equals x squared looks like this. What happens when you stick a 0 in front of the x squared? So when it's 3 squared would be 9. Normally it's 9 times 0, it would be 0. Let's look at 2. 2 squared would be 4 times 0, it would be 0. 1 squared times 0, it would be 0. So your graph will look like this. Basically, it's not very useful. So we forget about the case of this thing being 0. Now, as a summary, hang on. As a summary, y equals x squared looks like this. Y equals 2x squared looks like this. Y equals 3x squared looks like this. So any number that's bigger than 0, it will bend upwards. It will concave upwards. Now, a number like y equals, let's say, negative 2x squared. So, hang on. In the case of y equals negative 2x squared, you would draw it like this. X squared, 2x squared looks like this. Because it's a negative 2, you just turn this thing upside down. So it will look like this. So when you have y equals something x squared, if this is a negative, it will concave downwards. If it's positive, then it will concave upwards. In the case of it being dead on 0, it would just be meaningless. So forget about the case when it's 0. Another thing is, hang on, y equals x squared looks like this. So there's a 1 here. Y equals negative 1, it will look like this. Well, you can have, let's say, 0.7 x squared. 0.7 x squared. So y equals x squared looks like this. Y equals 2x squared looks like this. Now, if it's between 0 and 1, it would just look, this is y equals 1x squared, but we don't bother writing the 1. In the case of it being 0.7, it would just be flatter. It would just be flatter. Y equals 0. Let's say 1x squared. It would be even flatter. So this a here, this number here can be 0 here. It can be a decimal in between 0 and 1. So in the case of it being, let's say, 0.3, it would just be somewhere around here. Okay.